Okay, so introduction to equations of lines. Take a look at that title, the form of the equation, y equals mx plus b. So that's going to be a form of a linear equation that you're going to use a lot. Okay, so it says complete the following table, rearrange the polynomials in descending order of degree where necessary. So the first two are already in descending order of degree. The third one isn't. So take a minute to do that, please. Then look at them. Look at them and decide what degree each of them is, what the leading coefficient is, and what the constant term is. So you have to remember back to the polynomials unit. Yes. Hold on a second. Okay, so the first one just has an x term, so it's degree 1. The leading coefficient, you look at that x term because it's the highest degree term, and the coefficient is 4. And the term without a variable is -3. Take the sign in front, right? Don't just say 3. It's subtract 3, which means it's -3. Next one, highest degree term. It's already in descending order of degree, so that's a degree 2 polynomial. The leading coefficient is the coefficient of the x squared term, so the 2. And the constant term is the one that doesn't have a variable, -5. Now the third one, as I gave you a hint, is not in descending order of degree. So we need to rearrange it. So the x to the 5th term goes first. And that's the degree of the whole polynomial. You don't add all the degrees together. That's only in a monomial. And then the leading coefficient is -5, yes. Take the sign in front, and then the constant term is +4. Okay. So really, we're just asking you to identify those. Okay, so difference between a polynomial expression and equation and function. So students get those mixed up all the time. So an expression doesn't have an equal sign anywhere. When you're simplifying it, your next line might have an equal sign, but you're just saying that the previous line is equal to it. So that's an expression. An equation obviously has an equal sign, but there's only one variable, so not 2. Like this one has y equals. So that means you can graph it. So a polynomial function, you can graph. An equation, you solve. You find the value of x. So for the rest of this unit, we'll be determining equations of lines and graphing them. So if you don't have a straight edge, make sure you get one, because you will be graphing a lot. A linear function is a special type of polynomial function. It's something like this when we make it equal to y, right? It's a function that we're going to graph. Those are all expressions. So we're going to look at deciding what it looks like. We already have spent time on linear relations, which were essentially linear functions, unless it's a vertical line. So you kind of already know some of this stuff. So the table below shows polynomial functions up to and including degree 3. Complete the table. Use your calculator to do the last column. So if you have a graphing calculator, get it out, okay? And this is where you may need to use it. So if you haven't got one yet, you should get one for this unit, okay? That's great. Write them down if you know the answers. Okay, so here the degree, notice how it's y equals just a number. So the degree is 0 if it's just a constant term. The next one has an x term, so it's degree 1, then degree 2, and then degree 3. We happen to put them in order, right? Leading coefficient, so the leading coefficient has to be on an x term, a term with x in it. So the first one doesn't have a variable term in it. So there isn't a leading coefficient. It's just that constant term. That's not a very good 5. Okay. In the next one, the leading coefficient is 3. The constant term is 1. The leading coefficient is 2 because it's 2x squared, and the constant term is 2. We put way too many 2's in that one. Should change that. That one, if you just randomly guessed 2, then you would have got them all right. And the next one, the leading coefficient is 4, and the constant term is 2. Okay, so let's practice. I've got a TI out. It's going to be similar for the Casio. So go to your y equals. In a Casio, you go to graph. Make sure you've cleared off anything that's already in there. Okay. Then you're just going to enter. So I'm going to do these all at once. So y equals 5, then I'll enter, and then enter 3x plus 1. Oops, it doubles up sometimes. Just a sec. Plus 1. Enter. Then 2x squared minus x plus 2. And then 4x cubed, so exponent 3. Cursor out of that. Minus 3x squared plus 2. This way we can do them all at once. It tells you what window. So this always means the x min, x max scale, y min, y max scale. They're just in order horizontally because, and so here I could also do it. Let me do it on the Casio. Cursor down to graph. Clear. Let's see. I want to delete one. Okay, so this one. So you change your window while I'm setting up my Casio here. Oops. Sorry. Okay. It doubles. I know. It doubles up when I'm using this on the screen. Okay. Doubled up again. There we go. Okay. Okay, and then okay, so enter on that, and if you're in the Casio, and then for Casio window settings, and what did we say? -8. Oops. -8 down to 8 up by 1. No, it's all of them. It's the window settings. So if you look on this is what we're asking you to do, from -8 to 8, up by 1s, in both directions. So I'm just doing it for Casio right here. And it keeps, sorry, scale 1. Okay, cursor down to y min. Okay, -8. We're doing the window settings. Okay, and then exit out that and graph. So draw for a Casio. Okay, you can see them there. I'll draw them in the TI. My TI screen is a little bit bigger, so I'm just going to do those so you can see it a little bit bigger. Okay, so just a little bit bigger in my Casio. So you can take a look at it. Some of you might have a color so you can see the difference. Some of you might not. If you're not sure which is which, if you trace on it, it will tell you the equation in the top right, what it's flashing on. So the blue one here for me is y equals 5. It always goes to the first one. Then if you cursor down, it goes to y2. For me, that's the red one with 3x plus 1. So both of those are lines, okay? Then if I cursor down again, it's on, a little bit hard to see which one it's on, but you can cursor left or right. It's on the U shape, which has a name of a parabola. That's the math name, and that's x squared, that's degree 2. If you cursor down, it's on pink, which is x cubed, and it's not a straight line. So there's just two that are straight lines here. So is this a line? Yes, yes, and then this is no, no. Okay, so as you can see, a linear function is a polynomial function that is either degree 0 or degree 1. What kind of line did degree 0 polynomial make? What's special about that blue line? Never. Horizontal, right. Horizontal lines have 0 slope. Okay, so if it's not horizontal or vertical, we call it an oblique line. And oblique lines are lines that are neither horizontal nor vertical. In general, all oblique lines are degree 1 and can be expressed in the form y equals ax plus b, where a and b are real numbers and a can't be 0. If a was 0, then we wouldn't have this term, and it would be a horizontal line. So an oblique line, we have to have that x term. Recall that if the line is in the form y equals ax plus b, then the leading coefficient is a, and the constant term is b. Okay. So turn over to the next side, and we're going to do some, remember back to our work with slope, basically. So line A is the blue one. It's a little bit hard to see the A, but you can see it there. Calculate the slope. So find two nice points on that line. So the y-intercept is a nice point, and x-intercept isn't, but this is a nice point. So now if I go up and to the right, then I'm going up 4 to the right 2. So my slope is 4 over 2, which is 2. You can just simplify it in your head. And I already plotted the y-intercept. It's 5. Okay. B is the green one. So x-intercept is nice there. So is the y-intercept. So I'm going to use that to draw my triangle. So -2, so down 2 to the right 4. So when we do that, remember you reduce it. That's -1/2. Okay, what's the y-intercept? Well, I've already plotted it. It's -2. So already, hopefully you see some patterns. Take a look. The slope here is the coefficient of x. The constant term, the y-intercept is the constant term. Same thing back in the first one. The slope is the coefficient of x. The y-intercept is the constant term. So that's always going to be the case. So when you have the equation, solve for y, the coefficient of x will be the slope, and the constant term will be the y-intercept. So now you can graph any line that's given to you in that form. So here, what we've just found is the slope of line C should be -1. So check and make sure it is. If I take this point and this point, down 3 to the right 3, sure is. It's -1. And the y-intercept was 3. If I look at line D, it's the orange one, y-intercept there at -7. And if I go up, it's not a nice x-intercept, but this is a nice point. So if I go up and to the right, I'm going up 4 to the right 1, which is 4. That's really the biggest thing of today, okay? When it's in slope y-intercept form, that y equals mx plus b, then the coefficient of x is the slope and the y-intercept is the b value. So the leading coefficient a is equal to the slope. Constant term is equal to the y-intercept. Okay. What letter did we use for a previous lesson to represent slope? We used m. So now, since a was our slope, it's going to be m. That's usually what's used for slope. Okay, memorize it. You'll use it forever now if you continue to take math, right? Why is it the letter M? Yeah, I'm not sure. Okay, so state the equation of a line with slope a half and a y-intercept of -3. Now that's really easy. That's the coefficient of x and subtract 3. Okay, that's your basic type of question on the next test. Notice how it says state because there's no work needed to be done. Equation of a line with slope of 2 and y-intercept of 0, but anytime you're adding 0, we don't show that. So we'll just show it as y equals 2x. So anytime you just have y equals an x term, you know the y-intercept is 0. There's no constant term shown. Okay. So now we're going to draw. So if you don't have a ruler, then use the back of your calculator, the battery, fold a piece of paper over. That'll work. But now we know, because we were doing this in the last unit, you were graphing a few lines, but now this is going to be given this information. Y-intercept of 3, slope of -2/5. So that means we go down 2 to the right 5, 3, 4, 5. Try to plot at least 3 points if the grid will allow. Notice how I can't go down and to the right again. So if my slope is -2/5, that's the same as 2 over -5. We never show it that way, but to get slope, that means we could go up 2 to the left 5. And then we would get another point on the line. So sometimes you might want to do that, because certainly it helps to fill up as much of the grid paper as possible, filling with points, because sometimes when you use a ruler, especially if it's not a ruler, you're going to be a little bit off when you join them up. Can you stop that, please? Okay, and then put arrows on the end. Because it's not an application, it's a line. So we're going to consider that it goes on forever. Okay, so you put arrows on the end. So the equation of the line, again, -2/5, that's your slope. So that's your coefficient of x. And then your y-intercept is 3. Okay. So now use that equation. Our coordinate grid is not large enough to find a point when x is 15, right? Because it doesn't go far enough. But we can use our equation to find y. So when x is 15, we will substitute 15 in for x. And then you will know what your y value is. Okay. So if we do that, that's going to be -30 divided by 5 is -6 plus 3 is -3. Okay. Now I'm going to show you on your calculator. So if you, let's do the Casio this time. So I'm going to, let's go to these. I'm going to clear off my equations. Delete. Yeah, we're going to graph it and see if we get the same answer. Oh, what just happened? Just keep the same window. And that's why I want to do this, so you can see what happens. Okay, so what did we say? It was negative 2/5 x. No, we're just putting the x in. And what was the y-intercept? 3? Plus 33, no, plus 3. Okay, so just gonna refresh it. I don't know why I have that in there. So enter on. Okay, so what happens with the Casio might be the same for some of you, is if you have a Casio and I press enter, notice how it puts it into fraction form with the x in the denominator. With TIs, you don't have to worry about it. So I need to fix this because I don't want the x in the denominator, right? So I'm going to put negative bracket 2 divide 3, or negative, in brackets, negative 2 divide 3. Close the bracket, then put x. Oh, is it 5? Yeah, sorry, 5. So 2 divide 5, and then delete 5, got a cursor, delete. Okay, getting there. It's got a lot of delete. Okay, and then plus 3. Okay, execute on that. Okay, so then it actually converts it. And then graph it. Now, if I, in a Casio, you go Shift F5, or just Shift here so you see G-solve. I think so Shift F5 gives you G-solve, F5 on that, and just enter, well, let's enter just 0. Okay, oh, sorry. Give me a sec. It's predicting. Okay, so now if I go, okay, so just do G-solve, and then arrow, and I want to calculate. So if I do an x calculate, it's going to ask me for a y value. So I want to do a y calculate. So I'm going to exit on that. So I'm going to do a x calculate. Okay, so my x value of 0 should give me my y-intercept. Okay, now if I do the same thing again with 15, it gives me an error. Okay, so why do you think it gives me an error? Do I see an x value 15 on my grid? No. So you have to change your window to be able to include that. It will be fine for y's that are beyond, but not for x's. So you would go to your window and go, let's go to 20 for x max, and then exit, then draw. Okay, now if we go G-solve, arrow, y-calc, x is 15, we should get negative 3. Okay, in the TI, so I'm just going to go to y equals, clear off these. And then here it was negative, oops. It was negative 2 divided by 5x plus 3. Graph that. If I go trace, it goes right to the y-intercept. If I try to put in 15, it will tell me the same error. So then if I go to, it'll flash. The x is too big. So I change my x max to 20, graph it, trace, If you just punch in the y value, or sorry, the x value 15, it will go right to the -3. Okay, so it's a good time to start practicing with your calculator before the end of the unit. Okay. Be able to use your graphing calculator. Okay, so a line is drawn to the right here. State the equation. So now we can come up with the equation. Okay, so we want to find the slope of this line and the y-intercept. Y-intercept's really easy. It's 4. So right now, I know it'll be +4. Then the slope, I need to find another nice point where the grids cross. So here is a nice one. So I'm going to go up to the right, so up 1 to the right 3. So my slope is 1/3. Make sure that that x is not in the denominator. Okay, so it's either to the right, or you could also write it as y equals x over 3 plus 4. Most times we show it as 1/3 because then it's obvious what the slope is. So use your equation to find the value of the function when x is 30. So now we substitute 30 in. These are nice numbers because 1/3 of 30 is 10, plus 4 is 14. Take a look at the next form, the next equation. It's not y equals, it's 2y equals. So if we want to get the slope and the y-intercept, we have to get it to be y equals. So just like solving any equation, divide both sides by 2. So now we'll have y, y equals 3 over 2x minus 4. So do that separately from this to be in slope-intercept form. If you were to enter it in a calculator, you can put it in whatever form you want, but when it's solved for y. But for slope-intercept form, we want it in that form. Okay. So now, because my pen went weird. So my slope is 3 over 2. So actually, I'll use the word slope. How about that? So slope is 3 over 2. And y-intercept, I'm just going to abbreviate that to y-int, period, is -4. Make sure you take the sign in front of it. Okay, next one says sketch the graph. Take a look, it's in decimal form. Take a look at the grid. The grid is not very spread out. So to go up 0.75 to the right 1 would be very challenging. Convert this to a fraction. 0.75 is 3/4. Now we know the slope is 3/4 and the y-intercept is -1. Okay, so we always start with the y-intercept. Whenever you're graphing, you have to start with a point. So the y-intercept and then the slope, up 3 to the right 4. I've run out of grid, but I'd like to get another point. So we could also show this or use -3 over -4 for slope, because that simplifies to 3/4. We never really, that's never our final answer, but it can help us get another point. So we can go down 3 to the left 4. And now you can join that up. And put arrows on the end. I'll have to fix that just a little bit once it's done. Give me a sec, it's frozen. Okay. Next ones, state the equation again, no work required. has a y-intercept of 1 and is parallel to the line -2/3 x minus 3. So if it's parallel to that line, who can tell me what the slope of the line we want should be? Exact same. Yeah, so this is easy. Oops, that's a line. This is easy peasy. Okay. Perpendicular to this line, who can tell me what the slope perpendicular to -2/3 is? Okay, hands up. Yes, 3/2. So y equals 3/2x plus 1. You don't keep the same y-intercept because it told you what your new y-intercept is. Okay. All right, next one, the equation of a line is defined by this. So we don't know what the slope is. We know what the y-intercept is, and we're told that it passes through this point. Yes, you could plot it, but why? Why spend the time? Determine means show your I would suggest showing your algebraic work. If it says determine and you want to do it graphically, you're going to need graph paper. Like you can't just sketch it. Okay, so at the point 2, 4, that means the y value is 4 when the x value is 2. And so we want to solve for m. We've already done some similar ones. I think there was one similar on your test. So we're going to add 6 to both sides. And so m times 2 is really 2m. Divide by 5 and show m on the left. So divide by 2, show m on the left, and you get 5 as your answer. So then what you could do is you could put the equation y equals 5x minus 6 in your calculator and make sure it goes through the point 2, 4. Sort of a different method of figuring out or checking your work. And similarly in the next one, we know the slope but not the y-intercept, but we're given another point. So the point is -4, 7. So 7 is your y. -4 is your x, and you need to solve for b. It's got fractions, but really this simplifies, right? That ends up being +6. So b is 1. Okay, so y equals -3/2x plus 1. And then turn over the page to horizontal and vertical lines. I just want to go back and check because it was fixed on this, I think. Oh yeah. So you know what? When we were checking these ones, I didn't compare here. Just go back to question 1 and there was an error on this. So this should be, this equation here should be y equals -1 plus 3. We didn't actually check because we were using these ones. So, oops, -x plus 3. So just go back and change that in case when you're reviewing, you wonder, oh, why is the y-intercept 3 when the equation is -6? So go back and fix that in your notes. Okay, so question 1, go back and fix it. So it would require you looking through your notes. Okay. So change it to y equals -x plus 3. All right. So, oops. Okay, last part, horizontal lines. So remember, we already talked about them. The degree is 0, and they are called constant polynomials because it's always the same value. So sketch the graph of y equals 3 and y equals -3 in your calculator. So I'll use a TI this time. So these y equals 3, y equals negative 3. You can use the same screen, whatever we had before. Notice they are horizontal lines. Okay, and those are the y-intercepts. So sketch them using your calculator, label each. So yeah, so now we're going to graph them on our grid paper here. That's really squiggly. I'm going to use my ruler. Okay. So put arrows on the end and label. So this was y equals 3. This is y equals negative 3. Look in the table of values generated by your calculator. So in a TI, if you look, the table is second graph, and it will give you the table of values. And you can change what you're going up by for x, but notice all the y values are 3 for the blue one, the top one. All the y values are negative 3. You don't really need your calculator to confirm that, but how do the y values in the table relate to the equations? So the y values in the table are the constant term in the equation. Can you stop crinkling, please? My abbreviation for equation is EQ apostrophe N. Okay, so without a calculator, draw the graphs of y equals 5 and y equals negative 1. I'll use a different color. I'll use blue. So y equals 5 would be up here. Y equals negative 1 would be here. Pretty easy to graph those if you have a straight edge. Okay, arrows on the end. Label them. So this is y equals negative 1. This is y equals 5. Okay. So usually we show it solve for y. Sometimes we'll put all the terms on one side, but not yet. We'll do that, I think, tomorrow. Compare them. So it says, what does the equation of a vertical line look like? So here, this is a horizontal line. What's the equation of this? This is y equals 2. Okay? The y value is always equal to 2. Now if we look at the vertical line, in the vertical line, the x value is always equal to 2. So what do you think the equation would be? X equals 2. It's all about patterns, right? Really. So that's x equals 2. Doesn't matter what y is, x equals 2. So now if we're going to graph these, maybe choose red. And so when x is negative 1, that would be here. Okay, when x is 4, that would be here. Doesn't matter what y is, x is always 4. Okay, and then arrows on the end for those. And we'll label those. So this is x equals negative 1. This is x equals 4. Are those vertical lines functions? No. No way. Right? Because there's an infinite number of points. If you put your pencil right on that, it's going to touch an infinite number of times. Are vertical lines the only lines that are not functions? Are there any other lines that you think are not functions? Yeah? What would they look like? But that's not a line. Yeah, it's a straight line. It's only this that's not a function, so no for that. Okay, so all vertical lines have that as their equation. Okay, so Listening, please. Says write the equation of the line that is perpendicular to the x-axis and passes through 0.41. You can use the grid above if you want. So it passes through 4,1 right there, and it's perpendicular to the x-axis. Is the x-axis is here? Is that horizontal or vertical? Horizontal. So perpendicular is vertical. So it's actually the same as this one that we already graphed. So it's this line here. I'll just freehand it. And so that's going to be x equals 4. It's basically x equals whatever the x value is of that point. And then use slope y-intercept form to write the equation of a line with slope 0. So that's 0x and y-intercept of 7. So if we use slope y-intercept form, then we'll have 0x plus 7, but then 0 times x is 0. So we really simplify it to y equals 7. Okay? Did you need to use slope-intercept form? No. It has a y-intercept of 7. So you can think about it. It's at 7. And it has a slope of 0. So you know it's a horizontal line. So it's y equals 7. Okay?